Good morning, science lovers. Ah, I love this place. You know, it's wonderful to have not just the facilities, but a community here at the DuPage Unitarian Church that welcomes those of us who are committed to understanding the world through the lens of science and realism. That's rare to find at a church. Unitarian Universalism has a history of accommodating different points of view, different epistemologies, and people who lack belief in the supernatural, and certainly people who love science are always welcome here. So it's nice to see you. This is our, something like 14th year, 15th year of doing Science Sundays. Mike has done it about a year longer than I have. I'm his understudy. One of these days I might be competent enough to not be an understudy anymore. Yeah. An overstudy. Yeah, I do that sometimes too, right? Okay, so today's topic, Dave, are we streaming on YouTube yet? Yep, okay. So today's topic is one that occasionally comes in and out of the news, and that's has to do with Mars exploration and visiting Mars, putting human footprints on Mars, well-booted footprints, and eventually settling Mars. So how many of you would go to Mars if given the opportunity? Yeah, a few, okay. Would you be willing to live on Mars if given the opportunity and a guarantee of habitability? Yeah? Oh, like we've done the best we can, you know. That's how guarantees go in space science. Because if something goes wrong, you're not getting any help, I'm sorry to say. And we're going to talk about that here in just a minute. So, is Mars the next frontier? Let's talk about it. So, here's a view that you may have in your minds, a sort of a conceptual view about Earth versus Mars. I mean, you can see things that kind of look like continents on Mars, those little different colored splotches, and you see poles, white ice. I mean, they look similar. Mars might be a little smaller than Earth, right? And it's a little further away from the sun, but we know how to do global warming pretty well, right? So maybe that's a possibility. So you like this picture, right? It's enticing. Well, let me show you a more realistic picture. This is Earth, and this is Mars. So Mars is a bit bigger than our moon, but it's not nearly the same size as Earth. If you were to add up all the land area on Earth across all the continents, the total area of land on Earth, remember we're like 78% water surface, if you add up all the land area on Earth, then you'll probably get to something about like Mars, right? So there's a lot of room to spread out, and that's not necessarily a bad thing. But there are consequences that come along with being a relatively small astronomical object. Here are some of those consequences. Mars has 10% of the mass of the Earth. I mean, it looks like it's a lot bigger than 10% of the Earth. Why does it only have 10% of the mass? Well, if you remember your high school geometry, volume goes like the cube of the radius, right? 4/3 pi r, or 3/4 pi r cubed, something like that. 4/3, yeah, okay. 4/3 pi r cubed. And so as the radius increases even a little bit, your volume goes up tremendously. And the volume is what contributes to mass. Also, studies of Mars and measures of its gravitational strength, the strength of its gravitational effect, indicate that it doesn't have an iron core. Or if it does, it's a very small iron core compared to the Earth. And it's certainly not a molten core that rotates like happens inside our Earth. So there's some consequences of that we'll get to in a moment. If you were to stand on Mars and get on a bathroom scale, some of you would be very happy, and myself included, to learn that you'd only weigh 38% of what you do on Earth, right? So gravity there is weak enough that extreme sports could be a whole new level of extremity, with high jumps and track and field and shot put and all of that. Mars has about 44% the escape velocity of Earth, so it's easier to get rockets up and down. And speaking of getting rockets down to Mars, one of the problems with getting things back down to Earth is that things tend to, well, not to put it too delicately, burn up in the atmosphere, right? And that won't, it's not nearly as dangerous on Mars because the atmosphere is much thinner. It's much cooler with a bigger swing between temperatures. On average, it's 78 degrees centigrade. Remember, a centigrade degree is about, for the sake of argument, 1.82 times the size of a Fahrenheit degree. So that's something like 100 degrees centigrade, or 100 degrees Fahrenheit cooler there than it is here. I'm sorry, what is it?
It's more like 150 or
150 or
so.
so, thank you. That's the average temperature. And there are a lot more temperature swings between night and day because of this less insulating atmosphere that I alluded to, among other reasons. No big oceans to act as heat reservoirs. The temperature swings on the surface of Mars are incredible, and you might call them uncomfortable. So that's a potential problem. Speaking of atmosphere, the atmospheric pressure at the surface of Mars is about 0.006 atmospheres, the atmospheric pressure on Earth. So a good way to say that in a more colloquial language is it's a vacuum. They still have just enough atmosphere to support dust storms and dust tornadoes and whatnot, but yeah, it's a dangerous place with almost no atmospheric pressure. What was that, Joanne? And helicopters. It does have just enough air that a really fast rotor on a helicopter can make helicopters work, as we saw a couple years ago with a little drone helicopter attached to a Mars Explorer robot. So the solid core that it has, the relatively small solid core that it has the implication that it has no magnetic field. And have you seen the northern lights that have been on display here the past couple years, a couple times, even at our latitude? The northern lights are a spectacular piece of evidence to support the claim, the assertion that we have a strong magnetic field around the Earth. That magnetic field acts like a shield, quite literally. It shields us from solar radiation and cosmic rays to a greater or lesser extent, depending upon the strength of those flying charged particles. A flying charged particle has another name. We call it radiation. And radiation may not always be good for a feller. So the lack of a magnetic field is problematic. We have a question or comment? Please wait for the microphone because people on YouTube would love to hear what you have to say.
I was also going to just point out that it's not just our magnetic field that's shielding us from radiation. That is one of the big things, but also our thick atmosphere is a pretty strong radiation shield. Right.
Thank you for that. Yeah. You're exactly correct. So the combination of a weak atmosphere and no magnetic field makes the surface of Mars a radiation paradise. I don't know if you should use those words together, but I just did. It also tends to have global dust storms, right? You've possibly seen the news that sometimes dust storms in the Sahara cause our sunsets here in North America to be colorful. There's also been some news about the fact that dust storms in the Sahara Desert spread nutrients, mineral nutrients from the Sahara Desert to the Amazon forest. So the Amazon forest in South America gets a benefit of the dust storms in the Sahara. So a global dust storm can't be all bad, right? Well, yes, it can be. Just look at Mars. So in Mars, the dust storms hurl around these sharp little particles of sand. There's no rain on Mars. If there ever was, it's been a few billion years since there was rain on Mars. And so the dust particles are little chips of rock that have been spalled off because of micrometeorite impacts and other celestial events like that. And the dust tends to be kind of as bad as asbestos, right? So imagine this carcinogenic dust that damages your lungs flying around everywhere in the atmosphere that you can't breathe under pressure that would cause you to bloat and explode. Pretty cool. I talked about the dangerous radiation. All right, so those of you who are interested in going to Mars, it'll at best take you about 6 months to get there using rocket technology. Unfortunately, physicists have not yet, and it may be that the universe precludes any kind of propulsion other than pooping stuff out the back of your rocket, right? So flying saucers with magical propulsion, there's no conceivable way that we can make flying saucers or jetliners or anything other than a rocket that must carry all of its fuel along with it. There's no other way that we know of to propel people into and through space. There's ion drives, but those aren't strong enough to lift you out of an atmosphere. So getting to Mars, best case, 6 months. Somewhere like 6 to 9 months to get you to Mars in your spacecraft that can't be too heavy because of all the rocket fuel needed to lift heavy stuff up into orbit and into space. So you're on your rocket on your way to Mars, and you've got this, I don't know, 4 inches of shielding between you and outer space. Possibly not terribly comfortable. There's a whole book I'm going to refer to at the end of this talk that talks about what it's like to be an astronaut and try to get by in space, and it's grueling, to put it gently. But you get to Mars. It took you 6 months to get there. You land. You find yourself in a dust storm and choking and unable to breathe and irradiated, and there's no food, and you decide, that's it. Nope, this isn't for me. I'm going back home. Well, okay, you have to wait 2 years. There's no popping down to Mars and popping back up to Earth, right? In order to get to Mars, you have to take orbital mechanics into account, the relative positions of Mars and the Earth. Sometimes Mars is on the far side of the sun from us, and that's about 230 million miles away. And that's prohibitively far. And by the way, how are you going to accelerate to get from Mars to here or vice versa, and how are you going to slow down once you get there? All of this stuff entails the use of rocket fuel and energy. Unless you do the 6-month to 9-month trip, in which case you can take a lot of advantage of the gravitational effects of things in the solar system, like the Earth and Mars and the Sun and whatnot. Anyway, once you're on Mars, you probably have to stay there for a couple of years, so there's no takebacks. Mars has a 24.6-hour day. That's close, right? We could probably deal with that, right? Well, here's what some scientists who studied the natural human circadian rhythm. If you're in a cave, for example, and you just wake up and go about your little cave life, and then you go to sleep, and it's always in darkness. They found that the human natural cycle tends to go towards like 24.1 to 24.4 hours. And daylight cycles, there's special signalers in your eyes that don't help you see, but respond to light and help set your circadian rhythm. In any case, somewhere between 24.1 and 24.34 hours is acceptable. Once you get beyond that, you start to feel persistent jet lag. If you tried to keep to a 24, this would be 24.6 hours, right? You would feel persistent jet lag, and it would only accumulate in terms of mental and physiological distress. So it's close, but not close enough. in terms of its day cycle. All right, so instead of hopping out of our space capsule au naturel and running around Mars, maybe we need protection, like spacesuits and whatnot. Maybe we can just build a whole infrastructure on Mars. We can have cities and maybe whole nations. Wouldn't that be awesome? A multi-species planet. I mean, we would be the first intelligent organisms in the solar system to be able to declare that. Wouldn't that be awesome? Multi-species planet. And, you know, certain multi-billionaires think, well, you know, we've done hard things before. Let's do the next hard thing, right? Let's not just go there. Let's settle there, right? Not only does it provide a multi-planet species opportunity, but it's high risk and high reward, right? I mean, think of all the dust that's there. It's also a great reason to mass produce rockets, which aforementioned billionaire is already doing, and part of that is with an eye toward eventually launching like 500 ships a year towards Mars to populate the first Martian city. But there are some problems with the idea of colonizing Mars. I mean, getting there, first off, as I indicated, is difficult, but once you're there, we can maybe colonize it. There's this idea of terraforming. I have a board game that some of us might play today called Terraforming Mars. It's such a popular idea, they're making games about it. And lots of science fiction stories have been written about the prospect of terraforming Mars. The Red Mars, Green Mars, Blue Mars series, etc. And I mean, couldn't we make Mars look kind of like that? I mean, this looks kind of like Earth. It's got clouds and oceans and a little moon. Wow, who wouldn't want to go there? Except it might take something on the order of a couple 100 million years if we tried really hard and expended vastly more resources than we have available to make Mars look like this. I mean, theoretically, if you talk to a theoretical physicist, they could say, yeah, there's an outside possibility that we could terraform Mars. But from a practical standpoint, it's not going to happen. I watched an interview, I did a lot of research for this, I watched an interview with Neil deGrasse Tyson where he said there's only 2 reasons that humanity has undertaken great perilous journeys. One of them is the prospect of wealth. You know, Jamestown, Virginia, one of the first colonies here in North America, you know why they were here? Gold. The Spanish explorers had found civilizations and deposits of gold and silver in South America, so people in England said, you know what? There's that whole other continent up there, I bet that's full of gold. So they came here looking for gold. It didn't work out so well. They didn't bring enough provisions to survive the winter because, hey, they were going to find gold and go back home. So one of the reasons to take a long, perilous, dangerous journey is economic. Well, Mars has a lot of dust. The other reason to take a long, perilous journey is geopolitical, right? Well, the Russians were doing a space program. We did a space program. It was a me-firster kind of race to see who could get the furthest when. And once we learned, this is what I learned from Neil deGrasse Tyson. He wrote a whole book about this. Once we learned that the Soviets were no longer interested in the moon, we canceled a pending moon flight. We just canceled it. Oh, this is too much trouble. They're not worth it. Let's just cancel it. Nobody else is going for that. So 2 reasons, economic and geopolitical. Hard to think of either reason being applicable to Mars. Maybe geopolitical. Yep, go ahead.
How about survival?
Survival, that's one of Elon Musk, I'm sorry, a billionaire who shall not be named. That's one of his perspectives is, you know, it's a place to go for survival of the human race. Well, it depends on what you mean by survival. Surviving for a couple of minutes, you could do that. Having babies on Mars, possibly problematic. There are lots of parts of human physiology that probably won't work really well in 40% gravity, 38% gravity. Some of that involves the plumbing necessary for reproduction. So, yeah, there's some problems with that. But hey, it's a cool idea. So a fresh start, a fun place to live and work. Yeah? Mars ain't the kind of place to raise your kids, right? In fact, it's cold as hell. That's true. He got it right. Elton John was a pioneer in terraforming. Self-sustaining colony by 2050. That's the goal of the aforementioned billionaire. Nope, not going to happen. I don't care how smart and rich you are. It's not going to happen. Okay, let's talk about the prospect of terraforming Mars. You can potentially make an atmosphere, and we'd need to replenish about 31,500 tons a year, because partially because Mars's gravity is weak, and so that atmosphere has a much higher statistical probability over time of percolating into space. And if your atmosphere percolates into space, there's a lot more space out in space than there is around your planet, and so eventually you lose your atmosphere. If Mars had an atmospheric pressure equivalent to what Earth has, it could be habitable for a couple of million years before the atmospheric pressure due to bleed off is problematic. So it's not necessarily a showstopper. The showstopper here is nitrogen. So there's probably enough oxygen bound up. It's a red planet. It's red because of iron oxides and other oxides. Industrially, chemically, you could use a lot of energy to split off the oxygen and possibly use oxygen innate to the planet to create oxygen in an atmosphere. Water may not be a problem on Mars either, but about 78% of our air is nitrogen. We don't yet think there's much at all nitrogen on Mars. So where's the nitrogen going to come from? Well, one clever idea is you bombard it with comets. Probably don't want to be there when that happens. And then there's catching a comet and redirecting the comet and aiming a comet at Mars and all. Yeah, that's just technical stuff. We'll deal with that later. So here's some more details about building a habitable atmosphere on Mars, a clement atmosphere. Let's just say it's really hard. It would be very, very difficult to build an atmosphere, and it would probably take more than just the duration between your lives and your great-grandchildren's lives. It would probably take something on the order of many centuries, perhaps thousands of years, even if we were to do it in earnest and throw untold resources at the project. So, again, giving Mars an atmosphere is not theoretically impossible, but practically speaking, it's an untenable hypothesis. All right, give you a minute to read any of that if you're interested. All right.
How did the term terraforming, can you just go into
Where did the term terraforming come from? Terra is, I believe, the Greek word for earth, terra firma, right? It has nothing to do with terrorists, which we might all be if we called our planet Terra. But terraforming is to take another celestial body, typically a planet, and make it like Earth. You're terraforming it. So that's where that term comes from. Thanks for the question. All right, farming Mars. Okay, well, maybe we can build bubbles, little glass or plastic bubbles, kind of like they did in that movie, The Martian. And I don't know, maybe we can use poop and fertilize the Martian soil, right? Like they did in the movie. The problem is the novel, The Martian, was written in 2011. In 2008, some science done by virtue of some of the rovers on Mars discovered that Mars's regolith. I'm not going to call it soil. Soil is a much more complicated thing than regolith, than rock dust. They discovered that the regolith on Mars contains perchlorates. I don't know, it's just chemistry. We can fix things with chemistry, right? Chemistry is no big deal. Perchlorates are poisonous. And perchlorates could be taken up by plants and passed along if you try to eat a head of lettuce into your body. And perchlorates interfere with, I believe, the liver and other parts of your biochemistry. Perchlorates are bad. They're bad for you. They're bad for animals. And so we need to get perchlorates out of the Martian regolith before we can think about adding fertilizer and organic carbon and nitrogen and other things to turn it into soil. Yep.
They're also extremely strong oxidation.
Correct.
So anything that's there is going to get oxidized, like iron and aluminum and carbon and nitrogen and all
Anything
of them.
that's looking for a home, a chemical that's looking for a home will find a perchlorate and screw up any other chemistry you're trying to do. Okay? Including biochemistry. So Andy Weir, who wrote The Martian, said if he had known about this, he didn't when he wrote his book, if he had known about the perchlorate problem, he probably would have used some other mechanism besides what's depicted in the movie and the book about just adding some organic waste to the regolith and growing food. There would be a necessary chemical cleaning step to remove the perchlorates. Or you just do hydroponics. You just grow it in water. Anyway, it has poor bioavailable nitrogen. So the regolith on Mars, again, is not soil. It's not dirt in the way that we think of dirt. It's tiny stone. It's sand, essentially. It's stone chips. It lacks organic structure, right? I've thought for a couple of years about giving a Science Sunday talk about dirt. Dirt is really fascinating. I mean, well, I could spend a whole Science Sunday talking about it, but it's not a simple thing, right? You don't just add nitrogen and carbon and suddenly you can grow things. Dirt is a very complicated thing that took, well, let's see. According to what I read, soil on Earth did not become a viable substrate to support plant life until about 450 million years ago. You remember Mike's depiction of the history of Earth? You know, Earth is formed out of molten stardust here, and then we're here. 450 million years ago is about here, right? So for the vast majority of Earth's history, there was no soil on this planet. It took billions of years to make a breathable, what we would consider a breathable atmosphere. It took billions of years, millions of years to make what we would consider a, what do you call it, tillable soil. All right. Turning regolith into soil, doesn't it start with lichens, right? I once had this most thunderous argument with a friend of mine. I won't recapitulate the entire argument, but we were up in the Boundary Waters area of Minnesota, roughing it, and he was talking to me about how the glaciers had scoured that area. Right? It's a very stony area, full of carve-outs, glacial carve-outs and whatnot that have turned into lakes. It's a glacier-blasted area of the country. And there are hundreds or thousands of lakes up there, and very stony soil. And my friend pointed at some lichen, and he said, you know how long it takes to make an inch of soil from rock? He didn't actually say that. What he said was, do you know how long it takes soil to be generated? It takes 10,000 years to make 1 inch of soil. And I said, because I was thinking about things like the Sphinx that was covered by dirt in 2,000 or 3,000 years, right? You leave something out sitting in your yard, and maybe in 10 years it's effectively buried underground, right? My friend was talking about to take rock and raw materials like rock and turn it into soil. It happens at about the rate of 1 inch of soil making every 10,000 years. But you can't even start with lichens on Mars. Scientists have done experiments to see how lichens thrive in space-like conditions, and it doesn't. So you'd have to start with simpler things, certain bacteria and whatnot. It's just really hard. The very prospect of terraforming Mars is to say the least, daunting. One of the other things we have available to us on Earth that causes opportunities and catastrophes is plate tectonics. Right? We recycle a lot of the material on Earth, from carbon to nitrogen and even water, they think now is largely driven underground at subduction zones and whatnot. We have this whole recycling mechanism built into the plate tectonics, by virtue of plate tectonics on our planet. No other planet we've discovered has plate tectonics. Maybe one of the moons of Jupiter does, but I think the jury's still out about that. Yep.
So talking about that, yeah, I know Io has volcanism due to the tidal forces from Jupiter kind of
Stretching
it around.
Yep.
And they think, but I don't think they've confirmed, that like Europa has plate tectonics of ice sheets, basically.
Yeah, so it's a rare thing, and on our planet it turns out to be vital to the recycling of elements that are implicated in supporting life as we know it. And silicon-based life, don't even get me started about that. That's just nonsense. Carbon dioxide is a gas. What's silicon dioxide?
Quartz.
Right, quartz. Well, anybody want to breathe quartz? All right. So the book The Martian by Andy Weir, I recommend both the book and the movie. It gets a lot of the science and engineering correct. And the book goes into even more detail and has a few more catastrophes he has to deal with that aren't included in the movie. But I recommend it. It's scientifically pretty accurate, except for the perchlorates thing and also the wind that causes the catastrophe at the beginning of the movie. I'm not giving much away when I say that. The windstorm is about the first 3 minutes of the movie. Wind on Mars is not nearly strong enough to blow an astronaut down, etc. All right, what about the idea of cities and nations on Mars, this idea of a multi-planet species? Well, there's no ecosystem aside from an artificial one. We would have to build it. It would be completely dependent upon technology, not nature, right? We've got water recycling and air recycling and soil regeneration. We've got lots of things that Mother Earth does by virtue of its natural processes that we would have to replicate on a limited and purely artificial scale. What would it be like to live in a habitat where oxygen is not readily available? Can you imagine that there might be cartels that want to charge you for the air you breathe? It would be exhausting. Thank you. Good, good. And what if you don't pay your air bill for a month? You go 3 minutes without air, yeah, I bet you'd be writing that check pretty quickly. All right. The other thing about, oh, there's another question. Yeah, go ahead.
It isn't exactly a question, it's a statement. I recently have been reading a book called Is Atheism Dead? Metaxas, the guy's name, the author's name is, the last name is Metaxas, M-E-T-A-X-A-S.
Okay.
The scientists who followed the scientists who declared, is God dead, in 1965, after the Big Bang Theory and all that other stuff, the scientists that followed that, most of them have become Christian because they, the science that they developed after the Big Bang Theory indicated that the Earth is unique in the universe. It's in the right location, the right size, the right conditions, the right everything, And, for humans to be thinking, that there is somebody else out there or some other living creatures, intelligent creatures, is fantasy. So I would recommend it. I keep going back to the first 50 pages that talks about this.
Yeah, so the specialness of Earth is something that's been commented on by everybody, including scientists. And we're in what's called the Goldilocks zone. I'm not going to delve too deeply into it right now, except to give to your thinking a little nugget of an idea called the law of large numbers. There are estimated to be something like 300 billion planets in our galaxy. 300 billion planets. And we know in detail about one of them. We know a moderate amount about 8 of them. There are, I'm not going to subtract 8 from 300 billion. There are 300 billion other planets we know nothing about. And so to claim that our planet is unique in the universe exhibits a kind of chauvinism that many scientists are uncomfortable with. Not to mention the fact that there are hundreds of billions or perhaps a trillion or more galaxies, each with their own hundreds of billions of planets. So making any kind of statement about, well, in the universe, based upon a sample of one, is questionable. Right.
A statistical fallacy.
Yeah. Okay. So if we were to try to build a habitat on Mars, it would require material to be shipped from a place that can manufacture plastics and perchlorate-resistant aluminum and other solar cells, probably, almost certainly, if we were doing it in earnest, nuclear power plants. Aforementioned dust storms are not really good for solar cells. Anyway, all of that advanced industrial equipment, habitat-forming equipment, would have to come from Earth. And it's really expensive. Somewhere I've got a slide that'll talk about the expense of lifting a ton into space. So the surface living, the technical term is multisyllable, forget about it, right? Also, have you tried to build something using space gloves? Have you tried to build something using winter gloves? Space gloves are worse, right? Imagine trying to work a ratchet wearing space gloves. Astronauts have problems with it. They have custom-built electric tools. By the way, electric tools, the battery-powered hand tools, that came from NASA, right? You can all thank NASA for the innovations that led to those. And they had to make special tools that had, big grips so that they could grip them with their puffy, gloved fingers. It's a mess. Okay, but there is some good news. There are gigantic caves on Mars. And these caves come with built-in radiation shielding. Also, these caves have built-in ability to regulate the climate. It's still cold, but at least it's constant. You don't go through the huge temperature swings that you experience on the surface of Mars. The moon has these too. I'm not going to talk about that much. So it's very likely that if we ever set up a semi-permanent human habitat on Mars, they'll be underground in these caves. They're called lava tubes, and they are gigantic. They make Carlsbad Cavern look like, I don't know, a tunnel dug by an ant, right? They are gigantic largely because the gravity is weaker, and so the tendency of the tubes to collapse or not form large openings in the first place is a lot different than it would be here on Earth.
Another thing about going down to live on Mars, if I remember correctly, and you might have something about this coming up, but the pressure gradient on the surface of Mars is much more dramatic depending on altitude. So that if you're like down in, I don't remember the name of the giant canyon on Mars.
Valles Marinas. Oh,
Yeah.
Yeah, I meant
Like
to
if you're down at the bottom
Yeah.
of that, like the pressure is like over an order of magnitude higher than
Yes,
the surface?
you're exactly correct. So we go from 0.006 Earth atmospheres to 0.06 Earth atmospheres at the bottom of Valles Marinas.
Wow.
So, yeah, welcoming. So, yeah, it's absolutely true that as you go down, right, you go down towards sea level, you go up into the mountains, pressure changes, right? Same thing happens on Mars, except the pressure differential, even though it's an order of magnitude off of something minuscule is still mini, right? Benefits, radiation shielding in one of these lava tubes, much more stable temperature, far less building material required because a lot of your structure is already taken care of for you, assuming that it's not too permeable to your atmospheric gases. Protection from micrometeorites and dust. I didn't really talk about micrometeorites that pelt the surface of Mars. It's spacious. You don't have to build a giant habitat, you just have to plug up the ends, right? And geologic stability. These things likely formed when Mars was volcanically active billions of years ago, and they've been there ever since, so probably don't have to worry about them failing. All right, here's some pros and cons of different options. A habitat on Mars. Sorry about that. Mars is calling, yeah. And then there's a habitat on Mars compared to a habitat on the moon, compared to a space station with a ring that spins, so it provides artificial gravity. And in a ring out in space in near Earth orbit, you provide a lot of the benefits of being shielded by the magnetic field of Earth. You're close enough for resupply and medical emergencies, which we just had one. First time ever, we had to send astronauts from space back to Earth for a medical emergency. That's hard to do if you're on Mars. So here's some pros and cons about different prospects for off-Earth settlements. And then to build a space station in near Earth orbit, something like 2 to 5 million, doable. 25 million to potentially build something in a lava tube on the moon, and something like 250 million to build a habitat on Mars. So orders of magnitude difference. And that money, if you're not going there for resources because of all the dust, then why are you going there, and who's going to be willing to spend $250 million? Maybe some rich guy or coalition of rich guys. Maybe, right? I can't say that's not going to happen, but it's a huge investment in something with no economic return. Now, the scientific value is amazing. There may have been primitive cellular life, microbes, on Mars at one point in its history. There was flowing water. So maybe there are microbes on Mars that we could discover. Maybe we could, I don't know, I doubt it, but maybe we could figure out something about whether it used DNA or not. And then imagine a telescope on Mars, unhindered by the problems of being deep in our atmosphere, or a telescope on the moon. And they're just scientifically, geophysics, planetary physics, laboratory experiments involving different conditions than we can make here on Earth. Great prospects for science in any of these bases, but not a very good prospect for a thriving community.
Potentially, maybe if you're like a billionaire who shall not be named and you saw these giant lava caves and stuff, would you think that maybe there could be a profitable income return on mining inside those caves?
Good. Mining. So it takes a lot to mine on Earth. Aluminum is an example. Aluminum used to be the most valuable metal extracted from Earth. I'm not sure about where platinum falls and all that, but aluminum was so valuable that the top of the Washington Monument in Washington, D.C. is capped not with gold or silver, but with aluminum. Not because aluminum was cool, but because aluminum was a sign of wealth and prosperity back in the 1800s. Now we have aluminum to cover our lasagna in our oven, right? But in order to make aluminum, the process of making it involves putting a huge amount of electric current into an ore called bauxite. So let's say we found bauxite on Mars. Are we going to waste a bunch of electrical generated energy just to make aluminum? Maybe. So mining Mars, turning it from dust or rock into usable material, it's probably more efficient just to send it up from Earth.
Regarding your telescope, I hear there's a lot of dust on Mars.
Oh, right. I forgot about that. Good point. Okay, so where should we settle? Well, here's a place we could settle.
Oh, is that Greenland?
This place offers breathable air, magnetic shielding, plenty of access to water, some soil, quick rescue, quick resupply. This is Antarctica. It's easier, it would be easier to build a colony at the South Pole than it would be to build one on the Moon or Mars. So if we're looking for more living space far away from the travails of society, just unplug and go to Antarctica. Yeah.
It's warmer there than on Mars, too.
Oh, good point. Yeah. Thank you. Good point. Yeah, it's also much more pleasant. Okay. So the idea of colonizing Mars is not a moral and accountability escape hatch. Some people, there's this idea, it's common in radical Christian ideology, this idea of dominionism. That the earth is ours to do what we will, and the faster we ruin it, the faster God comes back to fix it. That's a real theological position that some people maintain, called dominionism. But it's not a justification for destroying the earth. The idea that we may be able to go live on Mars is also not a justification for destroying the earth. And then I haven't even begun to scratch the surface about the political and legal challenges entailed in settling space. Who owns it? Is the concept of ownership even valid? Do we have to pay for the air we breathe if we lived there? Who controls that? Who has the shutoff valve? Right? It's just not going to happen anytime soon. We are doing a pretty good job of messing up certain aspects of this planet, but there's still vast vistas of beauty available on our planet that are perfectly commensurate with life and even human life. The lady who was here who was talking about the special nature of Earth, one of the things that I wanted to say, and I will say in response to her, even though she's not there, and I wanted to say in general, is we have evolved on this planet. It's not surprising that we are perfectly fitted to the environment in which we find ourselves, because we've evolved to be consonant with that environment. If there were temperatures conducive to water-based chemistry, liquid water-based chemistry, with solvents and solutes and enough organic molecules available somewhere else in the universe, then we could potentially imagine species that evolve on those planets, in those places, as long as there's water and warmth and the possibility of biochemistry. This is the planet we've evolved on. We fit it perfectly. It's not that it fits us perfectly. It's the other way around. We evolved to be acclimatized to this planet. If we go into space, in order to be acclimatized to wherever we go, we need to take parts of this planet with us. It's one of the reasons my personal belief, not proven by science, my personal belief is that our robot progeny are more likely to explore the cosmos than we are. It's already happening with the rovers on Mars. So Earth versus Mars. It's far better, the notion of spending a lot of money to clean up the mess we're making here than it is to look for an escape hatch out among the stars. All right, any questions or discussion? Okay. Oh, I get to do this one time. I will disintegrate you with my disintegrator. Thank you.
So I can probably reassure my daughter that my grandsons aren't going to be signing up to colonize Mars.
Yeah, your grandchildren, yeah, they shouldn't sign up. Yeah.
I'm always fascinated by watching those videos of the surface of Mars with the the rovers that are there with the cameras panning around. And when we talked earlier about tectonics, I see what looks like different jagged, crooked layers of broken sedimentary. And is that an indication of tectonic activity?
Great question. It's not an indication of tectonic activity. It is an indication that water once flowed on Mars. Scientists are pretty certain that that's true. Here's some books to read, and if you read one book about colonizing Mars, read this one. And it's also funny, so it's a good read. All right, another question or comment?
You talked a lot about Mars, and obviously that was the whole topic today. But what about the moon?
Yeah,
It's
what about the
moon? It's our satellite.
Right.
And what about that?
Yeah, so on the moon, gravity is substantially weaker, so the idea of having babies and whatever leads to babies and other biologic processes become more complicated at best. The mineral composition of the moon and the moon's regolith is not as rich in oxygen, and it has no carbon dioxide. So Mars gets a head start in terms of some of the chemistry that we would need. And the moon similarly lacks the shielding that also applies to Mars, but it is closer, so it's a day trip to the moon rather than a 3-year there and back again to Mars. Right. Other questions, comments?
So I've heard a lot of the reasons that I didn't even think about when it came to like colonizing Mars and stuff. And when I'm thinking about it, I've heard discussions from like theoretical scientists about other planets like Venus and stuff. From my point of view, that also seems a little bit crazy, but there's some basic ideas around that now are starting to hit me, like the fact that Venus has an atmosphere, tectonic activity. It has like little bits of oxygen up in the upper atmosphere that are covered in water vapor. Do you think that maybe based on those attributes alone, Venus might be an unlikely, like more, I don't know, between the two, if you had to choose between Mars and Venus?
If I had to choose between Mars and Venus, I would still pick Mars. The most tenable thing I've seen about colonizing Venus is giant hot air balloons floating at a middling altitude in the Martian atmosphere. It wouldn't be as hot, and the pressure on the surface of Mars is enough to easily crush you. I think it's like 90 Earth atmospheres. And so floating in the clouds of Venus, you're deep enough that you can't see the sky. You just are in this eternal gloom, and the clouds that surround you are made of sulfuric acid. So it's as plausible as certain other notions. There's no scientific reason why that idea is stupid, but there are probably other reasons it's stupid. All right, well, thank you all for coming today. I hope you enjoyed the discussion about Mars, and I hope to see you at another Science Sunday soon.